Hello everyone. In this video, we are going to have a look at deletion in single linked list after we did with the insertion in a single linked list in a last video. In this video, I am going to show you animated delete from the beginning, delete from an end, and delete a specific node followed by its C implementation. Let us now have a look at delete from the beginning. So this is my existing list from which a first node is required to be deleted. So a node to be deleted is a 20 data value. Now when I say that first node is required to be deleted, header is required to be shifted to point to a next node. The address of next node, we are going to get it from a node which we are going to delete. So we say that address which is stored in the link part of 20 will be now stored in a header in order to remove this link and making it point to a node number 10. When header is pointing to a node number 10, we don't have any way to reach to a node number 20. So this node is deleted from the beginning. Now let us have a look at its implementation. Now when I write a delete begin function, I'll have a pointer p which will be initialized with header in order to delete that value in order to read its address. Now first of all, before deleting, I'll have to check for if header is null. If header is null, it indicates that list is empty and we cannot delete a value. In other cases, what we have to do is we have to get a address from a link part of P, because P would now be pointing to a node number 20 in our example. So get an address from a link part of P and store it in a header. So as to make header point to a next node with a data value 10 in our example. So this is a simple function delete beginning. Now if you want to delete a value from an end, this is bit complex task because we have to traverse to a list in order to find the last node, and we have to update an address in a second last node. So here we are going to take two pointers P and Q, initially pointing to a first node, whereas continuing unless and until P gets the last node. So every time P moves ahead, P checks for a address field. It is a valid address field, it is not null. So P gets incremented to point to a next node. In the first iteration, Q remains there only. In other cases, Q will follow P. So every time P points to a node, Q will point to its previous node. Again over here, P checks for an address field. Address is a valid address, it's not null. So P gets incremented to point to a next node and Q points to a previous node of P. Again over here I can see and it's a valid address, it's not null. So P is required to be incremented to point to a next node, whereas Q points to a previous node. Now when P reaches to a last node, it gets that a value in an address field is null, indicating that P is pointing to a last node. As we cannot go back to a previous node, this Q pointer will help in writing a null value in this particular address field, that is a second last node. So we say that P is a pointer which points to a particular node in a list, whereas Q follows P. Now when we know that P is at last node, we will stop incrementing P pointer and we will just write a link part of Q to be equal to null. So we got our last node, this is deleted, that is an address of a node 30 is deleted, null is moved over there, and here we have a node that is deleted. Let us have a look at its implementation. So delete from an end, I am taking two pointer P and Q, again checking for the condition. If header is null, indicating list is empty, every time you delete a node you'll have to check for a list to be empty. If list is not empty, we'll go for a while loop. P is already initialized with header and Q is also initialized with header. So P and Q points to a first node in the list. Now Unless and until link part of P becomes null, we are going to continue iterating a while loop, shifting a pointer P to point to a next node, and Q will get an address from P. That means Q will follow P. Once we are out of this while loop, indicates that P is pointing to a last node and Q is pointing to a second last node. Once we are at that position, we have to just move a link part of Q with a null value so as to delete a node P. Now we don't have any ways to reach to a node P. We can print the value that is deleted for our reference. Let us have a look at a delete specific. When I am making call to a delete specific function, I will be coming with a value to be deleted. So for this example, I am taking a value 5 to be deleted. So again, we will take two pointers P and Q initialized with header. When P and Q is pointing to a first node, it will check for a data value. If it matches a desired data value to be deleted, it will delete. Otherwise, it will continue as in the previous case. It will just continue pointing to a next node. Every time P moves ahead by one position, Q will also move ahead except in the first case because P and Q was pointing to a same node. Again, that is, it is not matching my desired data values, so P and Q will be incremented to point to a next node. Now I found the data value matching my value to be deleted, so I found my desired node. Once I find my desired node, what we have to do is we'll have to update a Q pointers address field. So Q pointers address field will be replaced by an address of the one that was lying in the P because P is a node that will be deleted. So the address stored in a P is now stored in a link part of Q. So this is nothing but an address of a node number 30. So this breaks the link and link to a node number 5, whereas creating a link to a node number 30. So this node gets deleted. Let us have a look at a delete specific function. Here also P and Q is initialized with header. I am coming up with a value to be deleted. First thing would be checking for is an empty list, followed by which here you can see I have taken a while loop which will continue till P not equal to null. Unless and until P is pointing to some valid address, we have to continue looking for the item. If data part of P matches my desired value, does mean I found a node to be deleted. We have to copy the address from the link part of P and we have to paste it to a link part of Q. So we say that node is deleted, and followed by which we will break the state while loop so as to come out of this while loop, and that would be an ending of function. Unless and until this desired condition is satisfied, you are going to shift your P pointer to point to a next node with this statement. Similarly, before we shift our P pointer, we have to copy that address in a Q pointer so that P will be moving ahead and Q will follow P. Once we are out of while, there may be two reasons. One is we are done deleting an element, and the other reason is I did not find my desired element. In that case, if I am not able to find my desired element, indicates that P would be null. So if P is null, we'll just print a value or print a message that value not found, and that would be an ending of a delete specific function. Thank you everyone for watching. Please like and subscribe to my channel.